Welcome to this session on SQL Ranking Functions. Ranking functions in SQL allow us to organize and analyze data with a high degree of precision. Let's explore how these functions can transform raw data into meaningful insights. Let's start with the introduction to SQL Ranking Functions. SQL Ranking Functions assign a unique rank to each row within a results set. This assignment is based on the values in one or more columns that you specify. These functions operate over a set of rows defined by a partition and are ordered by specific columns, giving you flexibility in how you analyze your data. Let's look at some of its key features. The first feature is analytical capabilities. Second, they follow window function syntax. And third is partitioning capabilities. Some of the common use cases are top-in analysis, sequential numbering, and competitive rankings. Let's understand the rank function. The rank function assigns a unique rank to each row within a result set based on specified values. When there are ties in the ranking, it leaves gaps in the sequence. Here are some key points about the rank function. It ranks rows with the same values equally and skips ranks after ties, which creates gaps. It is perfect for competitive rankings. Here is an example of the rank function syntax. First, select the name score, and then use the rank function over order by score in descending order, as rank from student scores. As a result, you get the name score and rank. Let's say Alice has a score of 95, and the rank is 1. Bob has a score of 95, and the rank is 1. Carol has a score of 90, and the rank is 3. David has a score of 85, and the rank is 4. Let's learn about the dents_rank function. The dents_rank function assigns a rank to each row within a result set, but unlike the rank function, it does so without gaps in the ranking values. It ranks ties equally but continues with the next sequential number. Here are some key points. It ranks rows with the same values equally, and there are no gaps in the rank sequence after ties. It is ideal for tiered grouping applications. Here is a dents_rank syntax example. Select the name score and use the dents_rank function over order by score in descending order, as dents rank from student scores. As a result, you get the name score and dents rank. If Alice has a score of 95, the dents rank is 1. If Bob has a score of 95, the dents rank is 1. If Carol has a score of 90, the dents rank is 2. And if David has a score of 85, the dents rank is 3. Let's understand the row_number function. The row_number function assigns a unique sequential integer to each row in the result set. It generates unique numbers even for tied values, based on the specified ordering. Here are some key points. It always assigns unique numbers, and there are no ties in the sequence. It is perfect for pagination and unique identification. Here is a row_number syntax example. Select the name score, and use the row_number function over order by score in descending order as row number from student scores. As a result, you get the name score and row number. Let's say Alice has a score of 95, the row number is 1. If Bob has a score of 95, the row number is 2. If Carol has a score of 90, the row number is 3. And if David has a score of 85, the row number is 4. Here's a comparison of the ranking functions. We'll cover the function name, description, example result, and best use for each. For the rank function, it assigns equal rank to ties and skips the next ranks, which means it leaves gaps. Let's look at the table of example results. The columns are name, score, and rank. Alice has 95 in rank 1. Bob has 95 in rank 1. Carol has 90 in rank 3. David has 85 in rank 4. It is best used for competition results, sports rankings, and traditional ranking systems. For the dents_rank function, it assigns equal rank to ties but continues with the next sequential rank, which means there are no gaps. Let's look at the table of example results. The columns are name, score, and rank. Alice has 95 in rank 1. Bob has 95 in rank 1. Carol has 90 in rank 2. David has 85 in rank 3. It is best used for tier-based systems, grade distributions, and categorizing data. For the row_number function, it assigns a unique sequential number to each row regardless of ties. Let's look at the table of example results. The columns are name, score, and rank. Alice has 95 in rank 1. Bob has 95 in rank 2. Carol has 90 in rank 3. David has 85 in rank 4. It is best used for pagination, unique identification, and top-in queries. Note: the order of rows with equal values when using the row_number function is non-deterministic unless specified in the order by clause. Let's learn about partitioning with ranking functions. Partitioning allows you to divide your dataset into groups and apply ranking functions separately within each group. Here are some key points. It resets the ranking sequence for each partition and is perfect for grouping data, for example by department, year, or category. It enables ranking within categories. Here is a partitioning example. Select department, employee name, salary, and use the rank function over partition by department order by salary in descending order as department rank from employees. As a result, you get department, employee name, salary, and department rank. For engineering, Alice has a salary of 90,000, and the department rank is 1. For engineering, Bob has a salary of 85,000, and the department rank is 2. For engineering, Charlie has a salary of 85,000, and the department rank is 2. For engineering, David has a salary of 75,000, and the department rank is 4. For marketing, Eve has a salary of 82,000, and the department rank is 1. For marketing, Frank has a salary of 78,000, and the department rank is 2. And for marketing, Grace has a salary of 72,000, and the department rank is 3. Let's explore common use cases for ranking functions. The first use case is top-in analysis. Find the top-in performers, products, or records in each category. Here is a code example. Select everything from a subquery. The subquery is selecting product name, category, sales, and using the rank function over partition by category order by sales in descending order, as rank from products where rank is less than or equal to 3. The second use case is pagination. Implement result set pagination for web applications. Here is a code example. Select everything from a subquery. The subquery is selecting product ID, product name, and using the row_number function over order by product name as row number from products where the row number is between 21 and 40. The third use case is percentile calculation. Determine percentile rankings for scores, sales, or performance metrics. Here is a code example. Select employee name, salary, and use the dense_rank function over order by salary in descending order times 100.0 divided by count everything over as percentile from employees. The fourth use case is removing duplicates. Keep only one instance of each duplicated record in a data set. Here is a code example. With duplicate CTE select everything, and use the row_number function over partition by email order by created as row number from users. Delete from duplicate CTE where row number is greater than 1. Let's talk about advanced techniques with ranking functions. The first technique is combining multiple ranking functions. Compare different ranking methods side by side for deeper insights into your data. Here is a multiple rankings example. Select student name, exam score, and use the rank function over order by exam score in descending order as rank. Then use the dense_rank function over order by exam score in descending order as dense rank. Finally, use the row_number function over order by exam score in descending order as row number from student exam results. This is useful for comparative analysis and understanding data distribution. The second technique is calculating moving averages. Use window functions with ranking to analyze trends and smooth out data fluctuations. Here is an example. Select transaction date, daily sales, and use the average daily sales over order by transaction date rows between two preceding and the current row as moving average 3-day from daily sales report. This identifies trends and patterns in time series data. Here is an enhanced version that combines ranking with window functions for deeper analysis. First, with sales ranked as select transaction date, daily sales, and use the row underscore number function over order by transaction date as day number from daily sales report. Then select transaction date, daily sales, day number, and use the average daily sales over order by day number rows between two preceding and current row as moving average 3-day from sales ranked. Here are the best practices for using SQL ranking functions. Choose the right ranking function for your specific use case. Use partition by to create meaningful groups when analyzing data across categories. Consider performance implications with large data sets. Combine ranking functions with CTEs for complex analysis. Remember that row underscore number requires a completely deterministic order by clause to ensure consistent results. Use meaningful column aliases for ranking columns to improve readability. In conclusion, SQL ranking functions are powerful tools for data analysis that help transform raw data into actionable insights. They enable sophisticated analysis techniques while maintaining the declarative nature of SQL queries. Mastering these functions will significantly enhance your data analysis capabilities. Here are some key takeaways. The rank function creates gaps in the sequence for ties and is ideal for competition standings. The dense underscore rank function has no gaps in the sequence and is perfect for tiered grouping. The row underscore number function assigns unique sequential integers and is excellent for pagination. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.